Hello there, this is Miss Nakayama. This is the last part of 9.1a. So I'm going to finish all the problems that we haven't done yet, and then you'll be on your way with knowing how to simplify and multiply radicals. So first part of part 4, because there are two, we got to jump down here to 29 after we do 16 to 21. So the first part of this part 4 is that we're actually going to talk about numbers if our index is not a 2 anymore, but a 3. So if it's a 3, y'all, then we got to think about our perfect cube. So I'm going to review those real quick. 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed, 7 cubed, and that's probably about as 7 cubed. No, I go to 9. 8, I should have written 10. 8, 9. Y'all know what 10 cubed is? Please tell me you know what 10 cubed is. Exactly. It's 1,000. Okay, so we got to know our perfect cubes, or it's helpful to know those perfect cubes. And again, you can't use a calculator on the test with a square root that simplifies radicals for you. Okay, I'm happy to tell you if yours does that, but practice without the calculator so that you will know how to do those. And remember what we talked about at the very first part is when you want to find these factors of perfect cubes. You're always going to, when you want to find the factors of the radicand, we're going to be dividing the index into the exponent. It's a simple way of doing that. But let's look at our first one here. We got the cube root of negative 54. And I would encourage you, if you've got a negative in it, bring it out first, because the cube root of negative 1 is negative 1. And then you don't have to worry about it. But if I have a cube, the negative comes out. 54 is 27 times 2. So it's the negative cube root of 27 times 2. 27's in my list right there. So it is a perfect cube. The cube root of it, I hope you wrote those down. The cube root of 27 is 3. So this is negative 3 cube roots of 2. Number 17. Cube root of negative 64x to the 7th. So the negative's going to come out. 64. And actually, I wrote it. Okay, so I'll just show you what I did. So negative, I left it because I keep it underneath for a while. So the cube root of 64, that's in the list, so I didn't have to write it again. Okay, but this time, because I'm dividing, I'm dividing the index into the exponent. Then when I do, or what we've always done before is, well, that's not going to be the case. So 3, think of your multiples of 3. 3, 6, and 6 is less than 7. That leaves me with 1 left over, because x to the 6th and x is x to the 7th. So 64 is your perfect cube, and x to the 6th is your perfect cube. Cube root of 64 is 4. Cube root of x to the 6th. You're dividing. This is what this is telling you up here. So what we did every time, we divided by 2 in the previous one. 3 goes into 6 2 times. So the cube root of x to the 6th is x squared. So this is negative 4x squared cube root of x. That x is not a perfect cube, so it stays underneath. I didn't underline it. All right, look at 18. Cube root of negative 250. Negative's going to come out, and 250 is going to be 125 times 2. 125, it's in that list. Cube root of 125 is 5, so this is negative 5 cube roots of 2. Cube root of 27, x to the 4th. Well, 27's in my list. All right, but x to the 4th, I'm going to see 3. 3 goes into it. The next one is 6. That's too big. So I'm going to write that as the cube root of 27, x to the 3rd times x. This is a perfect cube. That is a perfect cube. Cube root of 27 is 3. Cube root of x cubed is x. So 3x cube roots of x. 128. I think we did that one earlier today. So I think 64 goes into it. And it's the cube root of 64 times 2. 64 is my perfect cube. Cube root of 64 is 4. So I get 4 cube roots of 2. 21, cube root of 8, x to the 8. 8 is in my list. So that's a perfect cube. But 8 to the x, remember we did it earlier, 3, 6 is still less than that number. So I'm going to rewrite this as cube root of x to the 6 times x squared. So when you have cubes, you can't just have one left over. So really, you're always going to be using this index number. So you want to think about the largest, how many times it goes into it. 3 goes into 8. That doesn't help you. That's a different way of doing it. Think of your multiples. 8 is the perfect cube. 6 is the perfect cube. Cube root of 8 is 2. Cube root of x to the 6 is x squared. Cube roots of x squared. All right. Now we got to go finish these last few challenging problems, okay, so that you can have no trouble doing the rest of your assignment. All right. So look at 29. When I start doing here, remember, if it's on the outside, it stays on the outside. So that's 3 times 4. And y'all, then I'm just going to break up 20. But when I do, because I have a 2 right here, I go, oh, well, that 2 goes into that one. So I'm using that number to break it up. 3 times 4 is on the outside. There's my 2. I always put the numbers together. So that's my 20. And I have a b squared and I have a b. Now, where am I perfect? This is square roots. So when I have 2 of something, it's a perfect square. 10 is not a perfect square, but b squared is a perfect square. So what comes out, 3 times 4 is 12. Then I get to bring out a 2, and I bring out a b. 3 times 4 is 12. I have 2 of something, I get to bring 1 out. I have 2 of something, I get to bring 1 out. What's left stays underneath. So that's 24b square roots of 10b. All right. Again, 5's on the outside, stays on the outside. I'm going to break up my 6 to 3 times 2, and then I'm going to put my c's together. So perfect square, perfect square. So that's 5 times 3 times c. Have 2 underneath, bring 1 out. Have 2 underneath, bring 1 out. 15c square roots of 2. It really becomes easier when you think about this when you have variables. All right, 3 times 2 is on the outside, and there's a 5. And guess what? 3 times 2, and then 5 times 15 is 5 times 3. So there's my outside numbers. They stay outside. Inside stayed inside. 5. 15 is 5 times 3. X and x is x squared. There's a perfect square, and there's a perfect square. So I'm going to have 3 times 2 is 6 times 5 times x. That became 5. This became x. 3's not underlined. He stays under. 30x square roots of 3. 32. All right. 6 and 2 stay outside. 5 goes into 10. So I'm going to write what that is. So that's 2 times 6 is on the outside. 5 is right here. 10 is 5 times 2. And a squared times a to the third, that's 5 of them. Well, 5 of them, I'm square root, so I just need an even number. So I have an even number here, and then what left over? Perfect square, perfect square. So that's 12 times 5 times a squared times the square root of 2a. Perfect square, brought out the 5. I got 2 of something, I bring out 5. A squared, that means a to the 4th becomes a squared. So that's 60 a squared square root of 2a. All right, we're on the home stretch, y'all. Last 3 problems. All right, this one, the same thing. I keep my numbers together because it makes it easier to, I think, to find your perfect squares. So 3 and the 4 are on the outside. 8 is 4 times 2. 10 is 2 times 5. But look, I found a perfect square here. I have 2 2's. That's a perfect square. Now, I'm doing square roots, so that's 2 and 7 is 9 t's. So 8 is a perfect square with 1 left over. So, again, I didn't have to know how to break up. I mean, if 10 times 8 is 80, and y'all might think that's easy, but it's harder for y'all to find what numbers go into 80 than it is for you to figure out what numbers go into 8 and 10. So, I got 3 times 4 is 12. The square root of 4 is 2. 2 2's give me a 2. So this is right here. Square root of 4 is 2. That's a perfect square. I get to bring one out. I got 8, so I bring out half of them. The 5 and the t stay underneath. And when you multiply together, you get 48t to the 4th square root of 5t. All right, same thing. So my 4 and my 4 on the outside. Now, I just broke it up to show y'all. I mean, just in case you didn't know. 8 and 5, 5 A's and 6 A's is 11. So I've got 1 by itself, and then I have the 10. That is the only perfect square. So that gives me 16a to the 5th, and then I multiply that back out, 42a. But it just is good practice. All right, 6 and 3 on the outside, 7 and 7 on the inside, and then I have 4 x's with 1 left over because that's 5 x's and that's 5. And then y to the 3rd and 1y is y to the 4th. 2 7s is a perfect square. That's an even number, so it's a perfect square. That's an even exponent, so it's a perfect square. So 6 times 3 is 18 times 7. So there's my perfect square. I bring 1 out. When I see 2 of something, I bring 1 out. Even exponent, take half of it. Even exponent, take half of it. The only thing left is square root of x. So that's 126x squared y squared square root of x. A mouthful, and we're done. Thank you so much for watching and sticking with me, y'all. I hope you have a great day. Please don't hesitate to email me or come see me if you have any trouble. Thank you so much for watching.